You take. Okay. Good morning.
Good morning.
Concentrate. Today we are going to learn architecture of 8086. 8086 is microprocessor, so we are trying to learn the architecture of 8086 microprocessor. This is what our goal is. Get it? Just make one thing very clear in your mind, that if you want to learn the architecture of any microprocessor, you need to understand your microprocessor is executing instruction. And if you are dealing with executing the instruction, you are doing three things: fetch, decode, execute. So you just need to trace in this microprocessor how the fetching get happen, how the decoding part done, and how you do the execution part. So if you do these three things in any of the microprocessor, you can learn any architecture of any microprocessor. Get it?
Yes.
Understand? Okay. Now first and foremost thing, your 8086 architecture is divided into two parts. One is called BIU, one is called EU. The BIU is bus interface unit, EU is called execution unit. Question number one: why there are two units in your microprocessor? You need to answer me. Why there are two units in 8086 architecture? Can you tell me? Do you remember anything from your past lectures? If you remember, 8086 is the first processor with pipelining. Yes? So we want to achieve pipelining. Now what we are doing in pipelining? There are fetching part done separately and execution part done separately. Yes? If you remember that carefully. So here BIU is the bus interface unit we are related, which is related with fetching part. Execution unit is related with execution part. So this is doing fetching, execution unit will do the execution. And you can achieve parallelism by pipelining because of these two. That's why you are having two units in 8086. Get it? First question is clear, why there are two parts. Done? Now, whenever you see this kind of symbol, this is arithmetic operations. Okay? If you can see this kind of symbol, there are two inputs. You can do some operation, you will get the output 3, 2 plus 5. So this kind of something design is nothing but representing arithmetic operation. Get it? Yes. How many such parts are there in this full diagram? Here it is ALU, arithmetic and logical unit, which will do the arithmetic operations in your microprocessor. There is one more such unit available in BIU also. Now can you tell me why there are two units? Why this unit is needed? This unit is needed because in 8086, if you remember segmentation, this is my microprocessor, this is my memory. Your memory is divided into number of segments. This microprocessor and memory is connected with address bus and data bus. Your address bus is of 20 bit. We can't use 20 bit, so we have created virtual address. What is virtual address? Segment address colon offset address. Segment address is of 16 bit. Offset address is again of 16 bit. And you need to count the physical address at the end of the day to do something. Yes? But as a programmer, we don't count the physical address. That is the task of microprocessor. So here is the arithmetic circuit available, which will do the counting of physical address from your segment address colon offset address. Get it? Understand?
Yes.
You are having two arithmetic circuits. One is in execution unit, one is in BI. This unit is having some specific purpose. What is the purpose? It is used to count the physical address. Why you need to count the physical address? Because we are using virtual address. What is virtual address? Segment address colon offset address. Both are of 16 bit. So 16 bit number multiply with 10 plus offset address, that is a physical address of 20 bit. Every time you need to count it, then only you can do something with memory. Understand? Yes? So for that purpose you require one circuit. So this is that circuit. Clear? Yes? You should ask me a question. The same task can be done by ALU also. Then why you need a separate circuit for that? You are having ALU, which can do any arithmetic operation. So multiplication and addition can be done by ALU also. Why you need one special unit for that? Again the same concept, pipeline. If you want to achieve pipeline, this should done separately than this. when ALU is in use in execution unit, we want to fetch the data. So we need some separate unit which can do this task for us. That's why this separate unit is needed. Get it? We want to do fetching and we want to do execution, and we want to do both these tasks parallel. Yes. If I am doing some execution part where ALU is in use, then I can't do fetching part. If the same ALU is used for counting physical address also, that is not possible. Yes. So I want one arithmetic logic unit which will do my physical address calculation. We need one ALU which will do my execution part. Understand? And both these things should work parallel. Then only I can get the pipeline working. Understand? Yes. That's why you are having one unit in BIU and one in E. Bus interface unit, as the name suggests, fetching part, EU, execution part. Clear? Yes. This is done. So what this will do? It will ask the variables code segment and okay. Let's come over here and then we'll go ahead. These are registers. All are 16-bit registers. Understand? Yes. What is this? ES register, CS register, SS register, DS register. These four are your segment registers. What do you mean by that? If I have stored 1, 2, 3, 4, X over here, what do you mean by that? My code segment in memory will start at location 1, 2, 3, 4, 0. Multiply with 10. Yes? Whatever value is stored over here is the starting address of your segment in memory. They are storing the starting address. Understand? If I am saying 1, 1, 1, 1 is stored in SS, what do you mean by that? My stack segment in memory starts at location 1, 1, 1, 1, 0, H. Understand? Yes? They are my segment registers. They are not segments. Segments are in memory. Understand? Yes. So these four are my segment registers, which we have already studied it. Yes. Now IP is instruction pointer. What is IP? Instruction pointer. It is again a register. It is 16-bit register. It is the offset for your code segment. Okay? Yes. And your IP is always pointing to the next instruction to be fetched. Just keep in mind, IP always point to the next instruction to be fetched. Just try to understand. If this is my code written over here, currently this line is in execution part. My IP is pointing on this line. Understand? If this is my code segment, here my code starts. So CS value will contain this address. Understand? And IP will contain this value, colon IP. Understand? So if I say 1111 IP equal to 0003 and this is 0000 1, 2 and 3. I am on this location. Understand? Get it? Yes. Your segment registers only use once to give you the starting address. Yes? Then to get your data, you are using offset address. It is only getting changed. So IP is changing every time. After every instruction, your IP value will get changed. Understand? Yes. When you go inside your program, CS will remain fixed because code segment is fixed where your code is written. The code segment में पहली 3 लाइन execute करी, हमारी चौथी करवानी चाहिए. Value को नहीं बदलाई, खाली IP नहीं. Your offset registers value will get changed. Your segment register will remain constant. Understand? We'll change our segment register only one time when we initialize. Afterwards, for our programming purpose, we only change IP value, मतलब offset value. Get it? Yes. Just for the revision, IP is 16-bit register, instruction pointer, used as offset register with code segment. Okay, and it always point to the next instruction to be fetched. Clear? Yes. Get it? This part is over. These parts are over. Done? Yes. Now there is something called prefetch queue. This unit is prefetch queue, and as you can see, there are 6 numbers here. 1, 2, 3, 4, 5, 6. Yes. Now, what is prefetch queue? As the name suggests, it prefetch something in advance, and it is a queue. Now, there are 2 data structures that you are going to study. One is called stack, one is called queue. Stack we have already studied. Last in, first out is your stack. Queue is something where first come, first out. Understand? A basic queue of your ticket bar. That is your ticket window, is your queue. Whoever comes first will get the ticket first and get out. Understand? Yes. So here a prefetch queue is there. What it will do? Your microprocessor go to the memory, find out the physical address using this. Okay? This is my memory. Now concentrate. This address is like 11101111111112, like this. Right? It is 20-bit address. This 5-digit is 20-bit hex number. This is my memory. Each location can carry only 8 bits of data. 80, 90, 12, 11, 18, something like this is written. Understand? You as a programmer write down program in assembly language or in higher level language. At the end of the day, when it comes to memory, it is stored in the form of binary, like this. Understand? Yes?
Yes.
So this is my program. Suppose. So my CS is pointing on 1111. So I am pointing over here. My CS work is O. Currently the value of IP is equal to 0000. So it points on location this 80. Understand? What my microprocessor do? My microprocessor get the value of CS and IP, count the physical address using this, go to this location. My data bus will fetch the value of 80, and that 80 will come in that inside this queue. Understand? This is what happens. Now this is 6-byte queue. Your prefetch queue is 6 byte. So this is my first physical address. Then IP value will get changed. So I will check the value of IP. Again go to the next location. Fetch the value of 90. 90 comes over here. 12 here. 11 here. Like this. Understand? So your prefetch queue is prefetching the instructions in advance for you. How many instructions will get prefetched in advance? No 6. 6 is the byte. Total 6 bytes can prefetch in advance. That doesn't mean that 6 instructions get prefetched in advance. Instruction size can get varied. Understand? Instruction size is not always 1 byte. It can be of 2 byte. It can be of 3 byte. The maximum size of your any instruction available in 8086 is 6 byte. Understand? If someone asks you a question, why the size of your prefetch queue is 6 byte? The answer is the biggest instruction of 8086 is of 6 byte. So what happens? My instruction comes over here, my full instruction comes over here, and then it will go to execution mode. So first your instruction comes to your BIU. In BIU it will go to prefetch queue. From prefetch queue it will go to execution queue. This is what the flow is. Clear?
Yes.
Yes. If my queue size is 4 byte, I can't store 6 byte instruction. Understand? So my queue should be big enough so that it can accommodate full instruction, at least one full instruction, right? So my full instruction size is 6 byte. Maximum size is 6 byte, and that's why the size of my queue prefetch queue is also 6 byte. Understand?
Yes.
Yes. This much stuff is okay. Okay. Now concentrate. Let's try to understand some basic programming of 8086. Okay, now MOV move AL, BL. This is my one instruction. So what I am trying to do, I am trying to move data from one register to another register. Left side is your destination, right side is your source. Just keep in mind always. Okay? Right now what is AL, forget it, they are registers, but I want to copy the value of this register into this register. This is the instruction. Understand? Now to understand this instruction, you are having something called opcode, which is of 8 bit. Understand? So I am having one opcode of 8 bit. Suppose FA. So whenever your microprocessor see FA, it knows that you want to copy the data from BL to A. Understand? Yes. Suppose I am having one more instruction. So it is 1 byte instruction. 8 bit of data is needed. Yes. Suppose my instruction is move AL, 25H. Now what I want to do? I want to copy 25H into A. Understand? Yes. Now I can have opcode for this full instruction. Is it possible? Suppose F8 is the opcode for this instruction. Will it work? No. Why it will not work? Because for 25 if I write down this, then for 26 I need to have one more opcode. For 27 I need to have one more opcode. I can have infinite opcode because there are infinite numbers. Understand? Yes. So opcode is not possible for numbers. Opcode is only possible for instruction and registers because they are fixed. Understand? So in this case, what happens? I will have opcode for move A. Suppose that opcode is F9. And if I write 25H, what my processor understand? By seeing F9, it knows that you want to transfer 8 bit of data into A. By seeing this F9, your microprocessor knows that you want to transfer data to A. Which data you want to transfer, that it doesn't know. That it can get it after this line, 25H. Understand? So 25 plus F9 is my 2 byte instruction. Understand? F9 requires 1 byte, 25H requires 1 byte. Get it? Third example. Suppose you write down move AX, 1122H. So this is 16-bit data. You want to transfer into AX. Again for this you are having one opcode F suppose, and for this 1122. So this is 3 byte instruction. Understand? If you don't get it right now, just forget it. The core concept is your instruction can be of different size. Clear? Instruction can be of 1 byte, instruction can be of 2 byte, instruction can be of 3 byte. What is the maximum size of any instruction in 8086? 6 byte. Why it is 6 byte? Because our prefetch queue is also of 6 bytes, so that it can accommodate full instruction. Understand? Yes. Concept is clear. This is okay. Okay. And every instruction is having its opcode. What is opcode? Operational code, which you want to actually decode. Get it? Yes. Now this is my prefetch queue. Okay. Now try to understand the structure. What our processor is trying to do. You have written one program in memory. Your program is stored in memory, RAM, 1 MB of memory. Where you have written in code segment. Yes. In my microprocessor, PIU comes first. It will find out the value of CS and IP. From that, it will go to this mathematical unit. It will find out the physical address. It will go to that location. Data bus will get the data, put it into the queue. This much stuff is clear. अब કેટલા ડેટા ક્યુમાં મૂકશે 6 બાઇટ પહેલા 6 ડેટા ક્યુમાં મૂકી દેશે યસ whatever data comes first, now it will go to control unit. Control unit will decode it. It is nothing but decoder. So if FA is written, you know that you want to transfer BL to AL. Understand? Yes. Control unit will tell your full execution unit that you want to transfer data from BL to AL. It will ask BL and AL to give the data, copy the stuff, and inform you that your task has been done. Understand?
Yes.
Yes. This is how full process done. The upper part is doing data gathering, control unit will do the decoding part, and execution part will be executing your instruction. Get it? Yes.
Yes.
Understand? Still. Now there are some questions in prefetch queue also. Now it is a 6 byte queue. So how many? Suppose I am having 6 instruction, each of 6 byte. How many instruction comes in advance in this prefetch queue? If I am having one instruction of 1 byte, all the instructions are of 1 byte only. How many instructions can prefetch in advance? 6. Your 6 instruction will come here in advance. Get it? Suppose my first instruction is 1 byte, second instruction is 2 byte, third instruction is 4 byte. First is 1, second is 2, third is 4. How many instructions will prefetch here? પહેલીની સાઈઝ 1 બાઇટ છે, બીજાની 2 બાઇટ છે, ત્રીજાની 4 બાઇટ છે. કેટલી ઇન્સ્ટ્રક્શન એડવાન્સમાં ક્યુ માં આવી જશે? ક્યુ માં કેટલી બાઇટ આવી જશે? સમજ પડે છે? 1 2 4. Your queue can handle 6 bytes. So 6 bytes will come into your queue. It doesn't care about instruction. તમારી ત્રીજી ઇન્સ્ટ્રક્શન ની 3 બાઇટ ક્યુ માં હશે, 1 બાઇટ બહાર હશે. સમજ પડી? You can prefetch half instruction also in advance. Why? Because it is queue. First come first out. એટલે પહેલી ઇન્સ્ટ્રક્શન બહાર જશે, બીજી બહાર જશે, એટલે ઓટોમેટિકલી ઉપર જગ્યા થશે. એટલે જ્યાં સુધીમાં તમારી 4 બાઇટની ઇન્સ્ટ્રક્શન અહીંયા આવશે એ આખી ભરાઈ જશે. સમજ પડી? Yes. So what I am trying to tell you is your prefetch queue can prefetch half instruction also in advance. એના માટે બધા ખાલી નંબર જ છે, એના માટે ઇન્સ્ટ્રક્શન નથી. Get it? So if someone will ask you in exam that can prefetch queue will fetch the half instructions? Yes, it can fetch the half instruction. Understand? Done. Next question. Suppose this is my queue, 6 byte. Okay, 1 2 3 4 5 6. 1 1 1 2 1 3 1 4 1 5. Suppose these are the numbers. So I have this much instructions already available in my queue. This is go for execution. These are the two instructions, matlab 2 bytes which is needed for execution. So now my queue will become like this. 1 3 1 4 1 5. Upper part is blank. 3. Understand? Yes. So next question is when your queue will get refilled. एक ऑप्शन तो ये છે કે આખી ક્યુ ને ખાલી થવા દઈએ પછી પાછી ફિલ અપ કરીએ. One option is this. Second option is once you get the first byte empty, fetch it again. What will be the better option? There are two options. One is let the queue gets empty and then fill it again. Second option, once your first byte gets empty, fill it. It is as simple as that. Which one is better? Second. Obviously first one is not the solution, then you don't get the advantage of pipeline. Then your CPU need to wait for one part where you need to fetch. Yes? So that's not the good solution. So good solution is what? Once your one byte gets empty, fill it up again. Again. Your 8086 is not doing like that. What it will do? When your 2 bytes get empty, at that time only your 8086 will refill it. Why? Your 8086 is only refilling your queue when you are having 2 bytes empty. Why? Because 8086 is 16-bit microprocessor. You can perform 16-bit operation in single clock cycle. Understand? If I am filling something after each byte, for filling 16 byte bit, I need to do 2 clock cycle. 2 bytes, 2 clock cycle. Understand? But if I can do the same thing only one time, still I can do the same operation. Understand? 8086 is 16-bit microprocessor. What do you mean by 16-bit microprocessor? You can perform 16-bit operation in single clock cycle. Understand? Yes? Okay. So if I want to fill up all these 6 bytes one after another continuously, I require 6 clock cycle. If I do 8-bit operation, I need to perform this operation 6 times. Understand?
Yes.
Clearly? But instead of doing that, my processor is having the capacity to go into memory and fetch the two location, put it directly. તો હું શું કરીશ? હું મેમરીમાં જઈશ, 2 બાઇટ લઈશ, મૂકીશ, પાછો જઈશ, 2 બાઇટ લઈશ, મૂકીશ, પાછો જઈશ, 2 બાઇટ લઈશ, મૂકીશ. My queue is get full in how many cycles? 3 clock cycle. So initially if required 6 seconds, now I require only 3 seconds to perform the task. Understand? So if my capacity is bring more textbook at the same time, it is like this. બાજુના ક્લાસમાં 6 ટેક્સ્ટબુક પડેલી છે, મારે અહીંયા લાવીને મૂકવાની છે. The one solution is go take one, put it. Go take one, put it. That is one solution. મને મારી કેપેસિટી ખબર છે 6 ઉંચકાઈ જશે. I will go take 6, put it. Understand? Yes. So same is your processor too. So your queue is only get refilled when your first 2 locations get empty. Understand? Because it can do 16-bit operation. Understand? Yes?
Yes. Yes.
Okay, there are some revisional. Prefetch queue will prefetch instructions in advance. How many instructions? We don't know. We are only caring about bytes. It can prefetch 6 bytes in advance. Why we don't care about instructions? Instructions can be of different size. What is the maximum size of any instruction? 6 bytes. So that it can get accommodated over here. Yes? Okay. In queue, when it will get refilled? When your first 2 locations will get empty. Not on 1 location, 2 locations. 16-bit operation will get performed. Clear? Now one more thing. In pipeline, we have studied that your pipeline gets filled when there will be a branching. What is branching? Jumping from one place to another. Your IP value will get changed. Suppose this is my code segment. This is my code. Understand? Yes. I am on this line. Currently, I am executing this line. My IP is pointing over here. Yes. Now we know the structure right now. So this 1, 2, 3, 4, 5, 6. These 6 instructions are already there in my prefetch queue. Yes. But when I have already fetched instructions in advance. So these 6 instructions are already there in my queue. Yes. Get it? When this instruction is executed, these 6 instructions are already there in my queue. Yes. Yes.
Yes.
When I am executing this line, my ALU gets to know that my conditions are false and I need to jump from this location to this location. Understand? This kind of scenario can come. So what happens? Now when you want to jump from this location to this location, you are actually, pipeline will contain these instructions. Yes? And these are actually now useless instructions. We don't want to use it. Yes? So what we need to do is, we need to flush it. So our queue will get flushed away. All instructions will get removed. The new instruction will get fetched from that IP. Understand? Because your IP value will get changed. Understand? Yes. So your pipeline gets filled when there will be a branching, and if there will be a branching, your queue will get flushed out. All 6 bytes that you have fetched in advance, you need to remove it. Understand? Yes. Good. So this is your PIU part, fetching the instruction. Once the instruction comes, it will go to control system. It will get decoded. That what you want to do. Your opcode will come over here. From opcode, you know that you want to add something, you want to delete something, you want to move something. It will get decided over here. Understand? Yes. And then it will send the signal to your execution unit that what you actually want to do. Complete. Now here. Now it is a simpler part than upper part. Here ALU will do the execution part. Very simple. No need to do anything. Here you are having 4 registers, 16 bit. All are offset register, base pointer, stack pointer, source index, destination index. We have already studied. Yes? Yes. These 4 are your offset register. All are 16-bit registers. All are used with some of the segment registers. Yes. And they are used by microprocessor. Yes. Okay. What is important for us is there are 4 more registers. They are look like this. Concentrate. Okay. They are called AL, AH, BL, BH, CL, CH, DL, DH. They are called general purpose registers. So as a programmer, you can use them to do any sort of programming. Understand?
Yes.
General purpose registers are used by programmers to write down the programs. Now L means lower byte, H means higher byte. Lower byte, higher byte. AL is 8-bit register, AH is 8-bit register. BL is 8-bit register, BH is 8-bit register. So individually they are 8-bit registers, but if you want to use them together, you can use like AX, BX, CX, DX. So when you see X, it is 16-bit register. If it is L or H, it is 8-bit register. Understand? Yes. If I am writing move AX comma something, what do you mean by that? I want to transfer 16-bit of data into AX. Understand?
Yes.
If I am writing move AL comma something, I want to transfer 8-bit of data into AL. Understand?
Yes.
Concentrate. Move CH, 05H. 8-bit operation or 16-bit operation? 8-bit, because it is H. Understand? CL, 8-bit. L or H is 8-bit. X, 16-bit. Understand? Same register you can use as 8-bit register also. You can use as 16-bit registers also. Understand? Clear? So these are your general purpose register. It is depending on programmer that how they want to utilize it. Clear? Suppose I want to transfer. This is my register AX. I want to transfer 11 and 22 over here. There are three ways of doing it. One, move AH, 11H. It will transfer 11. Move AL, 22H. This will transfer 22. I will get 11, 22. Understand? Same operation I can do move AX, 11, 22H. It will get copied. Understand? Both are same. Just for the understanding. Clear? Registers are used as 8-bit registers also. They can use as 16-bit registers also. It depends on the program that how they want to utilize it. Clear? Yes?
Yeah.
Now everything is over. This is last part. Okay, your ALU is connected with two more registers. Both are 16-bit register. One is flag register. Okay, for flag register we will cover full flag register in next lecture. Just for the information, flag register will give you the status of previous result. This is what you need to remember. Flag register is giving you the status of previous result. So whatever instruction is executed by ALU will generate some result. Based on that result, there are some status which will get changed, and they are changing at flag register. Understand? So flag register is getting changed by each and every instruction. After each and every instruction, your flag register gets changed. Understand? How it gets changed, that will study in the next lecture. Clear? Yes. Now there is something called operands. Now operand register is a 16-bit register which is used by your microprocessor for temporary purpose. Now when you need temporary variable at many places, for a simpler reason, suppose I want to copy B into A. I want to exchange these two values. Value of A should go to value of B, B should become A. How to do the program? Temp equal to A equal to B, B equal to temp. This is what you do. Yes, swapping of two numbers. If you remember the program, you require some temporary variable where you can store the initial value, then you can swap the values. Yes?
Yes.
This temporary value can be stored in operand. So operand is a temporary register used by your microprocessor, not by us. So we are never going to utilize it. Clear? Yes.
Yes.
Yes. Full diagram is clear.
Yes.
There is one small information. There is one line from here to here. So prefetch queue માંથી ડેટા કંટ્રોલ યુનિટમાં જવા સિવાય ડાયરેક્ટ તમારા એક્ઝિક્યુશન યુનિટમાં જાય છે. દેખાય છે? Your queue is containing instruction. So instruction must go to control unit to get decoded. Then why there is a line which will directly go to execution unit? Understand the problem? What is the problem? There is one line which allows data to go from queue to your execution unit directly. Right? Officially, your data should go from queue to your control unit, then to your execution unit. Yes? But just we have studied in this lecture itself, there is one instruction called move. So suppose AL, 05H. Understand? We know that your opcode is for instruction and register. It is not for data. So my opcode is for this. Suppose my opcode is ABH. So while ABH, seeing this, your control unit knows that you want to add 8-bit number to AL register. Understand? Yes. Just by seeing this 8-bit number, your processor knows that you want to add something into AL. But what you want to add, that depends on this number. Understand? This number can be F8, AA, BB, whatever the number is. Currently the number is 0, 5, H. So this is also a part of instruction. Understand? Yes. My instruction contains opcode. At the same time, it also contains operands, which can be used inside your instruction. Understand? Yes. So in my queue with A, B, H, I will also store 0, 5, H. So what happens? This A, B, H will go over here. Your controller will get to know that, oh, you want to actually add number, and that number is 0, 5. So this 0, 5 will directly go over here and added with A. That's why there is a line. એટલે તમે 8086 નું આખું આર્કિટેક્ચર દોરી દેવો ને આ લાઈન ડ્રો નહીં કરો તો 0 મળશે. You need to understand the concept that each line has some meaning. Understand? Yes.
Yes.
Now just you need to repeat with me what's going on, and then we'll done. Here memory interface is your segment memory. Yes? Chalo. I am having 10 line of code. Concentrate. You need to answer me well. 10 line of code. 2 lines are already executed. I need to start with my third line. IP is pointing on my third line. 1, 2, 3, 4, 5. This is my CS. Yes. These 2 lines are already executed. Here my IP is pointing. Now tell me what your microprocessor do. First is your CS value and IP value will get fetched from here. It will go to here. Find out the physical address. It is 20-bit address. It will go to memory. In memory it will go on this location.
Yes.
Here suppose 88H is written, that 88H will come on this line. It will come here, store here. Yes? Same way IP will get incremented after each instruction, so it will get incremented. Same way you can fetch this 6 instructions, 1, 2, 3, 4, 5, 6. So that 6 bytes will come over here. Yes? Yes? While this process is going on, at the same time, that initial 88 will come to this control unit. It will get to know that you want to do some operation. According to that operation, it will send signals to your execution unit. 88 will go to here, execute that part, answer will be stored or something. Meanwhile, another one instruction will get prefetched. Yes? Get it? Fetch, decode, execute. Clear? Yes. Prefetch queue size is 6 byte. Why? Prefetch queue is of 6 byte. Why? Because yes, the maximum instruction size in 8086 is 6 bytes. Suppose I am using currently Intel i10 whatever processor is, and the instruction size is, suppose maximum instruction size is 20 byte. What will be the size of prefetch queue in that case? 20 byte. You need to keep it, then only the full instruction get filled up. Yes? When your prefetch queue get refilled, after 2 bytes get empty. Yes? Not on 1 byte. Clear? What if there is a pipeline? IP value will get changed from one location to another. What I need to do? If my IP value will get changed from this location to this location, what happens? IP change, there is a branching. Branching, pipeline fail. Pipeline fail, flush the queues. Keep this in mind always. If I am saying that my IP value will get changed, there will be a branching. If there will be a branching, there will be a pipeline gets fail. And if there is a pipeline fail, you need to flush your queue. Yes? Yes? What is the use of operand? Temporary register used by your microprocessor, not by you. Okay? AH, how many bit register? AH, how many bit register? 8 bit register. BL, how many bit register? 8. LH, lower byte, higher byte, all are 8 bit register. AX, 16. DX, used by user. Understand? If I am writing move AL, 88H, how many bit operation? 8. AH is 8 bit. Move AX, something. How many bit operation? Move CX, something. Move CL, something. Very good. Clear? Get it? Okay. Is there anything left? IP is instruction pointer, always pointing to the next instruction to be fetched. Keep in mind. Okay? it is not pointing on the current instruction. Current instruction is already in execution unit. We are always pointing to the next instruction because it is in DIU. Understand? Yes. So this is your architecture of 8086. Thank you.